Hello everyone. In this video, we are going to discuss a numerical on preemptive priority scheduling algorithm. In such a numerical, you will be provided with arrival time, burst time, and priority of the process. So the priority number can either be lower the number, higher the priority, or higher the number, higher the priority. This can be specifically mentioned in the question, so pay attention to it. If not, you can assume lower the number, higher the priority. So let's begin with this example. So first thing you need to do is to draw a blank Gantt chart and plot the arrival of the process. For example, here P1 arrived at time 0, P2 arrived at time 5, P3 arrived at time 12, P4 arrived at time 2, and P5 arrived at time 9. So plot the arrival of the process. Preemptive scheduling, preemptive priority scheduling algorithm checks the priority of the process. If a process is executing and a new process with a high priority arrives, then the new process is going to preempt the currently executing process. So let's see this particular example. Time 0, P1 is the only process in the system. So P1 will start with the execution. At time 2, a new process, that is P4, is arriving into the system. Now it will check the priority, compare the priority of P1 and P4. So P1's priority is 2, whereas P4's is 1. So P4 being the highest priority, it's going to preempt P1 and start execution, whereas P4 will wait. So here the execution we will be showing with a solid line, whereas the waiting we are going to show it using a dashed line. So now P4 is executing, whereas P1 is waiting here. At time 5, a new process, that is P2, arrives into the system. So priority of P2 is compared with P4. P2's priority is 0, whereas P4's priority is 1. So P2 being the higher priority process, it's going to preempt P4. So you can see P2 is preempting P4 and it's continuing the execution, whereas P4 waits for CPU. Time 9, P5 process is coming into the system. Now priority of P2 is compared with P5. P2's priority is 0, whereas P5's priority is 4. P2 being the higher priority process, it continues the execution, whereas P5 will wait. Time 12, P3 is entering the system. Now P2's priority is compared with P3. So here P3's priority is 3, whereas P2's is 0. P2 being the highest priority process, it continues the execution. So P2, it starts at 5 and continues the execution without any preemption, and it will complete at 33. Meanwhile, all other processes are waiting, and hence it's shown using the dotted line. When P2 completes the execution, we need to compare P1, P3, P4 and P5's priority and see which is the highest priority process. So in this case, P1 2, P3 3, P4 P1 and P5 4. P4 being the highest priority, P4 will continue the execution. So P4's burst time is 10. Earlier it has executed from 2 to 5, 3 seconds. So left out is 7 seconds. So it will start at 33 and complete at 40. After P4 completes the execution, P1, P2 and P5 are compared. Sorry, P1, P3 and P5 are compared. So P1 being the highest priority, P1 will continue the execution. So P1's burst time is 11 and earlier it has executed for 2 seconds. So now 11 minus 2, 9 seconds are left out. So it's start at 40 and completes at 49. Now we have P2, I'm sorry, this should be P3. Now we have P3 and P4. So P3 being higher priority than P5, P3 will execute and its burst time is 2 seconds. So it will start at 49 and complete at 51. So this is P3. Okay, it will start at 49, complete at 51. Next, last left out is P5. It will start at 51 and execute for 16 seconds and complete at 67. So like this, we need to draw a Gantt chart, and based on this Gantt chart, we can easily compute the waiting time and turnaround time. So let's see that. So here, waiting time of the process. So I've plotted all the process here. So let's compute for P1. P1's waiting time, if you see the length of the dotted line. So here 40 minus 2. This is the waiting time for P1. So 40 minus 2, 38. For P2, you can see it's a 0. For P3, 49 minus 12, so 37. P4, it is 33 minus 5, so 28. P5, it is 51 minus 9, so 42. So once you computed the waiting time, turnaround time is very simple. Waiting time plus the burst time of the process. So 38, P1's burst time is 11, 38 plus 11, 49. P2, 0 plus 28, 28. And P3, 37 plus 2, 39. P4, 28 plus 10, 38. P5, 42 plus 16, 58. So in this way, turnaround time can be calculated by adding wait time and burst time. Next, what you have to do is you have to compute the average wait time and average turnaround time. Just add this divided by 5. Add this divided by 5. Number of context switches. Context switches is the switching of CPU from one process to other process. If we leave the initial and the final context switch, the number of context switch will be 1, 2, 3, 4, 5 and 6. If we include them, it will be 8. So in this way, easily you can solve the preemptive priority scheduling algorithm by paying a little attention and drawing the Gantt chart carefully. Hope you understood this. Thank you.